Hello, welcome back to my channel Physics Magic by Habib. Thanks for watching my videos and subscribing my videos. And in our last video, I discussed about work done by variable force with very good examples. I hope you watched it. You learned the concept. If anyone you or your friends missed it, ask them to watch. The link is sharing in the description, so they can watch and they can get enough information regarding that. Now today, another very important concept we are going to discuss, that is conservative field, non-conservative field, conservative force, non-conservative force, potential energy. About this all we are going to discuss. First, if we discuss about the conservative field, and very familiar term to you, in this the work done is independent of path followed. Simple. In a conservative field, the work done is independent of path followed. I will explain you in detail. Let us suppose 2 points here, A and B. This is point A, this is point B. So work is done in this way, in this path. Say, let us suppose it is case 1. And work is done in this way, like in this path, it is case 2. Then work is done like this, it is case 3. So I can say here WAB is equal to WAB is equal to WAB. That's it. And in simple way I can say here, so W1 first case is equal to W2, second case is equal to W3, third case. So such fields we can call as conservative fields. And conservative fields are, you can take examples of gravitational field, electric field. These are the best examples for the conservative fields. And in this one, this is a basic and very important information. And the second point in this one is, this is the first one. So the work done is independent of path followed. That's a point number 1 you remember in this. And the second very important point is, let us suppose this is point A and you have done work like this. You reach to point B and from there you have done work and you reach once again A. Means it is a closed circle. So in this case, the work done will become 0. So the work done in conservative field along a closed path is 0. Remember, the work done in conservative field along a closed loop or closed path is 0. Say here, so WAB is in the first case. So this is the second point. WAB, work done in this process, in this path. And then WBA, like this, reverse. So this is equal to, we can write like this. Then you bring this side, then WAB plus WBA is equal to 0. So the work done along a closed path becomes 0. So this is another important characteristic of a conservative field. Now based on this one, the previous, even in JEE main also sometimes questions came. So what kind of questions we used to get in this? Let me explain you. I hope you understood this concept clearly. Then we will go to this. Let us suppose you have done work like this here, then work done like this, then work done like this. So started at A, went to B, then to C, then C to A. So A to B, B to C, then C to A. So reach to original point. So as per our just previous discussed point, this is a closed path. So the work done, total work done should be equal to 0. Then question sometime he will give like this. Say WAB is given 5 joule. Say this is say 10 joule. So WBC is given 10 joule. Then WCA is equal to how much? This work. How simple question it is. You may be feeling that very simple conservative field, so we can do easily like that, you may be feeling. But if you are not aware of that particular previous point I told, then definitely you cannot do that. But if you know this, then definitely very easy to you, because as per our knowledge, WAB plus WBC plus WCA is equal to 0. Then WAB is 5 joule plus WBC is 10 joule plus WCA is we have to find. Therefore, from here you will be getting it is minus 15 joule. How easy? 10 plus 5, 15. If it goes this side, it becomes minus 15 joule. So like this, you may get the questions in NEET based on the conservative. So 3 important points I told. So the first point is conservative field means the work done is independent of path followed. Work done or not, that is important. But in which path we have done, that is not important. So that is one point. And the second point is, in a closed path or along a closed path, the total work done is 0. And the third one, I gave the examples like gravitational field, electric field, magnetic field. These are all the examples for the conservative fields. And in this one more important point also you remember, there is no loss in energy. Energy loss will not take place here. The total energy will be stored in the form of potential energy. So the total energy will be stored in the form of potential energy. So this is all about the conservative field. Then the force in this we can call as the conservative force. About that I'll discuss. But before that, let us discuss about non-conservative field also. So in a field, in this field actually the work done depends on the path followed. So it is not independent, but it depends on the path followed. And the second very important point in this is there exists some loss in energy. Energy loss takes place in the form of sound or heat or light, like this. So there is loss in energy. So there is no question of storing of energy. So potential energy will never exist in non-conservative field. How important point I told you. So finally you understood, potential energy will be only in conservative field. And potential energy will not be defined in non-conservative field. How we came to know this? Because there is no loss in energy in conservative field, but there exists some loss in energy in non-conservative field. That's why here there is no storage of energy. That's why no potential energy we will define in non-conservative field. And the examples of this particular field is, you can take when frictional force is acting in a field, then it can be considered as a non-conservative field. Viscous force acting, that field will also be considered as a non-conservative field. So I hope you got two differences mainly between conservative and non-conservative fields. Then, as in conservative field case, I told you the energy will be stored, or whatever the work done in the conservative field, it will be stored in the form of potential energy. So let us discuss about potential energy. Potential energy. So the energy possessed by a body by virtue of its position, its position, or by virtue of its state, or by virtue of its condition, we can call as potential energy. For example, in a conservative field, I told you repeatedly, make an underline for this. This will be defined only in conservative field. The best example I told you, gravitational field. Say for example, a stone is lifted in a gravitational field like this. So the work, whatever you have done, that work done will be stored in the form of potential energy. The stone, when it was on the ground, it is not having any energy. But the stone, when it is lifted to this particular height, the same stone only, but now it is gaining some energy. It is having some energy. How this energy it got? Because its position is changed. Students, you remember, very important. Please focus. The stone earlier, it was on the ground. No energy it has, any special energy. Now it is lifted as the reference of the surface or reference as ground I am taking, not gravitational center and all these things. Simply, I am considering the original position of the stone is on the surface of earth. Now it is lifted. Now its position changed. So by the change of this position, now this stone is having some extra energy or special energy. That energy we are calling as potential energy. But how it got that potential energy? Because you have done some work. In order to change the position from here to here, you have done some work. The stone by itself, it is not going up. In order to lift it, you are doing some work to whom? Against to gravitational force. So that work will be stored in the form of potential energy. Like another example I'll give you. A spring is fixed here, then another end of the spring you are pressing like this. The moment when you leave this hand, immediately the spring will be enlarged like this. But when the spring is in its normal condition, it is not having that kind of energy or temperament. You take like this, spring is pressed like this, and you keep 1 rupee coin on this and you leave your hand. Immediately that 1 rupee coin will, raise up. The same spring only, but how it got some extra energy? Because in pressing the spring, you have done some work. That work will be stored in the form of potential energy in the spring. So the moment when the hand is removed, immediately that energy throwing the coin up. So this is the example of potential energy in case of gravitational field or spring case I have explained you. And in any conservative field, just I explained you, the work done in any conservative field is equal to minus delta U, where U is potential energy of the system. So this is a universal formula. Work done in conservative field is equal to minus of delta U, change in the potential energy. The reason why minus is coming here, it's very simple, very simple. Because you take simple example, you will understand. You take a spring, then the moment you are enlarging the spring, then what will happen? You know well here, the conservative force will try to pull it back. The spring will try to pull your hands close. Then if you want to go in the direction of that field, because conservative force is asking you to come close. Listen carefully, don't confuse. This is a spring. So you are enlarging the spring. Then what will happen? Your hands will feel that the spring is pulling your hands close. Okay, so conservative field is forcing you to come close. So in the direction of that expectation, in the direction of that conservative field, if your hand moves, automatically, you know well what will happen, potential energy decreases. So enlarged spring is having more potential energy, but as per its expectation you are coming close, then automatically the spring is coming to its normal stage, so its potential energy decreases. So in the favor of conservative field, if we go, potential energy decreases. In the favor of field, if you go, it decreases. Against to the favor of or against to conservative field, if you go, potential energy increases. That is indicating that negative sign here. I hope you understood very clearly. So this is very, very important formula which will help us a lot in future. Then after this, about this potential energy some more detailedly I will discuss in future. Now, before that, let me explain about another very important term which is called conservative force. Conservative force is another very important one, and based on the potential energy we'll define that. Conservative force is nothing. The forces in conservative fields are conservative forces. Gravitational force, the force present in the gravitational field is called gravitational force. Similarly, electric force you can take, magnetic force you can take, spring force you can take. All these are the conservative forces. Then conservative force, how we will find? Then conservative force is equal to negative gradient of potential energy. A new term I am introducing here. Remember, the conservative force is defined as negative gradient of potential energy, where this delta is equal to dou by dou x of I, dou by dou y of j, dou by dou z of k. This is called del. And this is not d we are writing because this is called partial differentiation. Remember nothing when you are looking at those symbols and differentiation, immediately I told you, in my last class, your heart will go down. Don't worry, Nana. Learn new things. Simple. Once if you concentrate and learn it, you will be in a position to explain others. So here, dou is different, d is different. So dou means it's a partial differentiation. Partial means, partiality means what? You will say that if 10 members are there in a class, if Habib sir repeatedly explaining only to 2 students, remaining 8 students, if I am not concentrating, then you will say that Habib sir becomes very partial. He is showing partiality only on 2. He is neglecting others. Am I right or not? The same here. Partial means when you are doing with respect to x, y, z we will ignore. Y, z will be considered as constants. So that is the meaning of partial. So when you are doing with respect to x, y and z will be considered as constants. Then when you are doing with respect to y, x and z will be considered as constants. When you are doing with respect to z, then x and y will be constant. But remember, don't worry, if I take one example and if I explain you, you will understand it very clearly. So this is about force F is equal to minus del dot U. Then I can write here minus, I can say dou U by dou X into I plus dou U by dou Y into J plus dou U by dou Z into K cap. So like this I can write. This is conservative. It's overlapped. 1 second, please give me a moment. Give me a moment. 1 second, please. So F is equal to minus dou U by dou X into I, so dou U by dou Y into J, so dou U by dou Z into K cap. Nothing I did, just a half day. Now in this particular concept, force can be easily find out if potential energy is given. So like this we can explain about the conservative force. Now we are going to do about this can also be written as in a simple way minus du by dr. So force is equal to negative gradient of potential energy. Like this also finally we can write F is equal to minus du by dr, and in this case this will give you du is equal to minus F dot dr. This can also be written. Potential energy we can find by integrating this equation. you will be getting potential energy. Like this, we can do. If we do one question on this, one numerical on this, you will be understanding with some more clarity. So let us do one numerical. Yes, let's do this question. Because when I wrote do, you worried a lot. Now, if I explain this example, then you will get it very clearly. Now, he's asking potential energy is given xy plus yz plus zk, zx. Then find force at 1, 1, 1. This is the question. Now, you know well here just only I told you solution we are doing here. F bar is equal to minus dou u by dou x into I cap plus dou u by dou y into j cap plus dou u by dou z into k cap. This is also previously asked question, but not in NEET, but another medical competitive examination this question is asked. So simply it is given like this. You know the formula. Okay. So then first we will find out dou u by dou x. Dou u by dou x is nothing but dou by dou x of the whole you write xy plus yz plus zx. And I told you just now, partiality you have to show. Partiality means when you are doing about this, you are not supposed to worry about that the remaining two. So then if you do like this here, you can see here the first one you will be getting here now dou u by dou x of xy, then you will be getting only y. Because dou x by dou x is 1, then y will be constant, I told you. That's why we have to write like this. But in this, no x term is there. So completely constant. Constant differentiation is always 0. So it is 0. Because no x term in this, when you are doing with respect to x, compulsory, if x is there in that term, then only we will consider the adjacent also as a constant. If x is not at all there, then the total term becomes constant and its differentiation becomes 0. Very simple. Here x is there, so that's why we are considering it is having its value. That's why I wrote y. But dou x by dou x becomes 1. That's why it is written only y. But yz, there is no x term. So when you are doing the differentiation with x, it becomes meaningless. So we will write 0. But here x is there. When x is there, it is having now its value. So now you will write here as z. But you know that here it is at 1, 1, 1. So x value is 1, y value is 1, z value is 1. Then it will become now, let us substitute directly. Then we will be getting here 1 plus 1 plus 1 plus 0 plus 1. It is nothing but 2. So similarly, dou u by dou y. So dou by dou y of xy plus yz plus zx is equal to. Now you can say, already you understood in the first one. You just say, if you have little confusion, you will get clarity here. So here y term is there. So definitely it will become valid. But dou y by dou y is 1. So only you will be get with x. Plus here also y is there. So z will become valid. But dou y by dou y 1. So z is only here. Now here no y term. Y term is not there, means there is no value for this. It becomes a constant. And constant differentiation always equal to 0. So it is 0. Now once again if you substitute here, you will be getting 2. Then the last one, dou u by dou z. Even if you do like dou by dou z of xy plus yz plus zx, then you will be getting z, xy, no z term. So 0, then y, then x, then 2 over. Looking very lengthy, very difficult, but simple. If you substitute this, then you will be getting, therefore force is equal to minus of, otherwise minus you can take out for all, minus dou u by dou x is nothing but 2, so 2y, then minus into plus minus, dou u by dou y is nothing but 2, then 2j, then dou u by dou z is also equal to 2, Therefore, minus 2k cap. This is nothing but the force. So, potential energy is given, force is asking. This is conservative force, because now my students got a very clear idea. Potential energy can be discussed only in conservative field. So that's the reason why potential energy is given, means definitely it is a conservative field. When it is a conservative field, that force is called conservative force. So that conservative force I found here, because this is fundamental formula which we have learned in the previous. You also remember, it won't change from question to question. 100% if you remember this, you can easily do. Method also have shown here. When you are doing with respect to x, you just see that whether x term is there or not. If x term is there, then only that particular term will become value. Otherwise, it won't have any value. You take here no x term is there. So 0 we wrote here, because it becomes constant for this differentiation. So differentiation of any constant is equal to 0. But if adjacent the term is there, then this will become constant, it will be left like that. This is the meaning of partial differentiation. So like that we can find out the force. I hope you understood this. Now let us discuss again. Okay, so just we have learned one important question. I think you understood the del operation also, how to find the force when potential energy is given. So explained you very clearly. Then let us go to the another very important concept, that is PE curve, means potential energy curve. What is this potential energy curve? Very simple. The graph plotted between potential energy of a particle and the distance of the particle from center of force. Simply, if you are not remembering all these things, potential versus a distance, this graph we can call as potential energy curve. Very, very important concept, ma. Please concentrate here. So let us discuss. This is the graph which I am drawing. So just I told you here, u will be taken on the x-axis, y-axis, and the distance will be taken on the x-axis. So the graph plotted between potential energy of a particle and its distance from the center of the force we can call as potential energy curve. Now let us draw the potential energy curve and let us analyze what happens to this and what is the nature of this curve, and where the potential energy will be minimum, where the potential energy will be maximum, where it becomes stable. Okay, all these things we will be understanding from here, and any question you can expect from this. Previously questions asked on this concept also. Now just listen. So in this case you can see here, so a graph is plotted, so we will get a graph like this. We will get a graph like this. Now if you analyze the graph, you will be getting a lot of information, because you are all familiar that the force is equal to minus du by dx in a simple form. Of course, minus del dot u is fixed, but in a simple way we can write like this: F is equal to minus du by dx. Now this is nothing but what? Du by dx means it is nothing but slope. Force is nothing but slope. Y component value divided by change in the x component value is always gives a slope. Those who don't know, you remember now onwards. If a graph is taken like this here, change in y component values, y values, say y2 minus y1 by x2 minus x1. If you take two different points on the y-axis, y1, y2, 2 points on the x-axis, x1, x2, then slope is equal to y2 minus y1 by x2 minus x1. So always you remember the change in y value divided by change in x value you are getting here. So we can write now force is equal to minus slope of slope of potential energy curve. So you got one more. When potential energy curve is given, then how to find the force also you got from here. This is another very, very important one, because sometimes he will give you potential energy curve and he will ask you force distance curve. Then what is equivalent of this force distance curve? Students, don't worry. Work power energy is a simple lesson, sir. Simple formulae are there. What you are explaining all this, then you may be feeling like that. But this is the original concept of the work power energy. If you learn the concept like this, any question you can do. Only formula if you learn, it won't help you. And I am minimizing all data also I am not giving, which is useful to you. That information I am giving. So please concentrate. Now if you see here, let us suppose this is point A, this is point B, this is C, this is D, this is E. Let us analyze. Now when it is going A to B, it is coming down. So slope is negative. Slope is negative. Slope means value is decreasing. I told you just now y2 minus y1. Then when that value is decreasing, slope will be decreasing. You are all familiar. If you draw a tangent here, you will be getting the slope. The slope is negative. So when the slope negative, already negative is there. So negative of negative becomes positive. So force is positive. How simple it is? You are worrying, but simple sentences I am using. Simple I am telling you. Slope, because it is coming down, definitely slope is negative. When slope is negative, already in the formula slope is here. Negative if you write, already negative is there. Negative into negative, positive. So force becomes positive. Then coming down here, slope is 0. Slope is 0. At this particular point only slope is 0. Slope is 0 means automatically force is also equal to 0. Because slope 0 means force is 0. Because no change in the y component divided by no change in the y component, especially because at the same point we are taking y2 y1 equal, y2 minus y1 is 0, so no slope here. So slope is 0, then it's going up. So slope is positive. Because it is going up, slope is positive. When slope is positive, you know well here force is negative. So while coming down, slope is negative, force is positive. Here, slope is 0, force is 0. Then while going up, slope is positive, force is negative. Because slope positive, if we substitute here, only 1 minus. So definitely force is minus. Then coming to this point. Once again, slope is how much? Yes, I know everyone is giving the answer. It is 0. When slope is 0, force will be 0. So then once again the same situation repeats here. Then it is going down now. It is here is constant. This is the another very important here. Here also slope is 0. Now this is the analyzation. Now you can say here where force is 0, these particular points we can call as equilibrium points. What are those called? Equilibrium points. So here is one equilibrium point you are getting. Here is one equilibrium point you are getting. Here is one equilibrium you are getting. And here is becoming straight line. Here only. Say for example it is becoming straight. So there also one equilibrium you are getting. Because force is 0 here. Force positive. Force 0. Force negative. Force 0. Once again same situation happens here. That's why I am not explaining this part. Then you go to this. Then slope is also 0 there. And in this case, here also you can say equilibrium point. This is one equilibrium point. This is another equilibrium point. This is another equilibrium point. So, equilibrium is there. Force is 0, but there is a difference. So, this point is different from this point and this point is different from this particular point. And this particular point we can call as stable equilibrium. It is called stable equilibrium, and this is called unstable equilibrium. this is stable, this is unstable, and this is neutral. So three equilibrium position points are there. So one is stable equilibrium, next one is unstable. I will tell you. I will give you a simple example. Sir, how to remember? How can you say this is stable? How can you say this is unstable? How can you say this is neutral? I will give you a simple example so that you will remember this. Say for example, you take a marble, a small marble, a stone you take, and just pull aside and leave. Then what will happen? It will oscillate like this and finally it will take rest here. So stable, it will become to stable position. I hope you understood. Then the same stone you keep here, then just pull it like that or throw it like that, then automatically it won't come back. Am I right or not? So that is called unstable. This is unstable. This is called stable. Here very clearly you can understand it is unstable. At any moment it will fall down. So it is unstable. But this is neutral because it's a plane. Say for example, on this if you put a marble like that, if you throw like that, it won't come back, it will go further. It will be stable. It will be neutral. So like that, in this three kinds of equilibriums we are getting. One is stable, another one is unstable, and the third one is neutral. I hope you understood. With examples I told you. Simply I didn't say. With examples I said here. Now in detail I will explain this. Here the three things for your convenience I have drawn in a simple way. You can say the first one is the stable equilibrium. The same, the part of the graph I have taken here, that's it. It is once again u and this is x. So ux graph only, some part is taken. So this is stable equilibrium. I told you also, if you take a small stone here, then if you just move it, then it will come back to its position. So this is stable. And these are very important conditions which will 100% important for NEET point of view. Then what about potential energy? It is minimum. Potential energy is minimum because it is coming down, it is minimum. More than this it is not going down. So it is minimum. But dou u by dou x is equal to 0 because no change at this particular point potential energy. And then dou square u by dou x square, this is very important. The second order differentiation of this one will become positive for stable equilibrium. It's a condition. For stable equilibrium, the condition, because dou u by dou x is 0 for this one, for this one, for this one. So with that we cannot say that what kind of equilibrium it is. It is stable or unstable, we cannot say. That's why this condition very important. So in order to check what kind of equilibrium it is, the second order differentiation only will decide. So second order differentiation, if it is positive, then it will be stable. If it is negative, it will be unstable. If it is 0, it is neutral. Understood? Very clear. So the first one is stable equilibrium, already I explained enough. Then u is minimum here and dou u by dou x is 0. Then second order differentiation is positive. This is very important condition. The net force is equal to 0 because it is equilibrium point. We are only saying equilibrium. At equilibrium force is 0. Then similarly you go to unstable. Here u is maximum. Look at that here. It goes up. This is second part of the graph. So it goes up. It is maximum here. Then dou u by dou x is equal to 0. Here also. Second order differentiation of this one is negative because it is coming down. So it is negative. Coming down, so negative. Net force is equal to 0. So this is very important, guys. Remember, because the question also will ask like that. Check it. What kind of equilibrium it is? It is stable or unstable or neutral. Like this only question will be asked. Then if you are not aware of this, then no use of this whole concept. No use of learning. That's why you remember, if it is positive, it is stable. If it is negative, it is unstable. If it is 0, it is neutral. That's all. So these are the important points on this. And if you draw force versus potential energy curve, you will be getting like this. Force versus x equivalent of this. So positive slope,
The negative slope, this part we are drawing here because force versus x this one. Similarly, force versus x we will be getting for this like this and for this like this. If you practice this, then definitely the question comes on this. You can do it 100%. Now, we will take one question also. I will explain you one question which is asked in the previous NEET examination. Along with year I will tell you. Then that question we will do. With that, the equilibrium concept will finish. So the potential energy of a particle in a force field is given U is equal to A by R square minus B by R, where A, B are constants and R is the distance of particle from center. For stable equilibrium, the distance of particle is. So potential energy equation is given and they are asking at what distance the stable equilibrium will happen. So there are two things we have to do here. We have to find out the distance for stable equilibrium. Second one, we have to prove that equilibrium is a stable equilibrium, because three kinds of equilibriums are there. So stable equilibrium we have to prove here. So two things are there. But first of all, let us take U as given A by R square minus B by R. And you know well here first what you have to find, slope you have to find. So du by dr is equal to d by dr of A by R square minus B by R. But this must be equal to 0 because the condition is that one only. For at any equilibrium, you know the slope is equal to 0. So du by dr is 0. U is given this one. So d by dr of this u I wrote here. Now let us differentiate this. Now how to do the differentiation? Therefore, differentiation of this one, A you write as it is. Now R square is there. R square means I am going to tell you a technique. Whatever there in the denominator, you take to the numerator that power with the negative minus 2. Remember, it will be very useful to you. Everywhere you can do like this. 2 you take to the numerator and add minus sign. Divided by whatever there power, add 1. So R cube. So 2 is there, added 1, it becomes 3. Now minus, same, B we will write here. Then power is 1. 1 should be taken to the numerator and minus 1 we have to write there. Divided by power should be added 1. So R square. Same thing Nana. Whatever there in the denominator, it should be taken to the numerator with the negative sign and add 1 here in the denominator. So power 1 taken to the numerator minus 1 added 1. So square we got. Then is equal to 0. Then from here if you further simplify, minus 2a by r cube minus into minus plus b by r square is equal to 0. Now let us say minus 2a by r cube is equal to plus, if you take this side, minus b by r square. Then minus minus gets cancelled. Then r square goes in this r times. Therefore r is equal to, here only I am writing, r is equal to 2a by b. So we found the distance. Two questions he asked actually. Find the distance he asked. But how simple? Procedure is very simple. Then he will give potential energy equation. We have to differentiate that one. Then equating to 0. Thereafter you will be getting the distance. R is equal to 2a by b you will get here. Now after getting this 2a by b, then we have to prove that whether it is stable equilibrium or not. So that how to do? Then you know well here we have to do second order differentiation. That we will do. So du by dr is this one and r we found in the previous calculation as 2a by b. Now we have to check whether it is stable equilibrium or not. For this what we have to do, you know well here. We have to find out the second order differentiation. If it is positive, it is stable. Listen ma, nothing to worry. Don't tension about these differentiation integration because these kind of questions will be very simple to do. Only the thing is guts. Only the thing is confidence. Then how simple I am doing. Techniques I am telling you. Simple tips. No need to remember also. Now here also we got this first order differentiation. We made equal to 0. Thereby we found distance. There ends the matter. But he is also asking in the question for stable equilibrium. We have to prove that whether it is stable or not. For that 3 conditions I told. Second order differentiation, if it is positive, it is stable. If it is negative, unstable. If it is 0, then neutral. Let us check. That happens only when you are doing once again differentiation for this. Therefore, d square u by dr square is equal to d by dr of this one minus 2a by r cube plus b by r square. Then once again same, I told you just now, minus 2a you write. Now whatever there in the denominator, that power should be taken up, minus 3 divided by r power 4. I told you just now, plus b, once again power whatever there, take to the numerator with minus, how simple technique you have learned today, divided by r cube. Then we have to check whether it is positive or negative. How to find? Then simple. Here only I am writing. Then minus into minus plus 6a by r power 4. Then plus into minus minus 2b by r cube. So the second order differentiation finally we got as 6a by r power 4 minus 2b by r cube. Now let us check whether it is positive or negative. For that r value you have to substitute here. Therefore, d square u by dr square is equal to then 6a by r power 4. R means this one by 4. Then 2 power 4 means 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 a power 4 divided by b power 4. It will go up. Then b power 4. Direct step I am writing. You can easily understand. This value we have to substitute here. 2a by b whole power 4. 2a whole power 4 means 16a power 4 by b power 4 goes up. Then what is the left here? Minus 2b r cube. Once again the same. 2 cube means 8. 8a cube. Then b goes up. Simple, nothing I did. 6a I wrote as it is. R value substituted here. Then 2a by b whole power 4. 2a power 4 means this one. By b power 4 goes up. Then we got like this. Similarly, this one I have done. Now what will happen? A goes in this. A cube will be left. Then b power 4. Therefore, finally what we got? 6b power 4 by 16a cube minus 2b power 4 by 8a cube. Then 2 3s are, 2 8s are. So 3b power 4 by 8a cube minus 2b power 4 by 8a cube. What is left? B power 4 by 8a cube. That's it. 3 times b power 4 by 8a cube. Simple. Here only. I will explain you if you want here. 3 b power 4 by 8a cube minus 2b power 4 by 8a cube. If you take this common, this if you take common, 3 minus 2 is nothing but 1. That is only I wrote here. This is taken common. 3 minus 2 is 1. I got. Definitely this is a positive. Because no negative symbol came here. So it is positive. So d square u by dr square is positive. So it is stable equilibrium. So like this we have to do. First order differentiation we have to do to find out the distance. Then you have to do second order differentiation. In that one distance you have to substitute. There you find. For example, if you get this one is minus b power 4 by 8a cube, then we we have to write here unstable. But we got plus, so that's why we wrote stable equilibrium. If you get 0 here, it is neutral equilibrium. Like that, this kind of questions we have to. Definitely you can do, Amma. So finally, very easy. Then stable equilibrium means second order differentiation should be positive. Unstable, second order differentiation is negative. Neutral, second order differentiation is 0. So to check this condition, we have to do second order differentiation. But for all these cases, first order differentiation is 0. We will find out the distance from the first order differentiation making equal to 0. Very simple, I explained, Anna. Looking very complicated, but once after this you practice once again, you only feel very simple. And I told you also how to do this differentiation also. Power taken to the top, numerator, minus sign, divided by add 1. All, everywhere you do like this only when denominator in differentiation you are doing. I hope you understood this clearly, and this is another very important concept. I hope you understood nicely. Very good. Okay, then we entered into the last phase of today's session, today's class. Potential energy, very detailedly we discussed. Now, in general cases, potential energy to find. For example, I told you the first example, when a stone is lifted to a height, then how to find the potential energy. So in such examples, say for example, if a body of mass m is lifted to a height h, if a body of mass m is lifted to a height h, then potential energy is equal to mgh. So potential energy stored in the body is equal to mgh. How we got this one? I told you already. In lifting the body from here to here, some work is done by the external agent. Okay, so work done by the agent means mgh. Work done by the gravitational force means minus mgh, remember. If I lift the body like this, I am the external agent. So displacement is also happening in the force direction. That's why it is positive. Work done only I found, nothing. Work done is nothing but potential energy. Work done means force into displacement. Force is mg. Mg force I applied. Displacement is h. So this h is the displacement. That's I wrote. So mgh. And another very important one is the spring concept. Spring. This is what you are all expecting. A formula if I give you will be very happy. In case of spring, force is equal to minus kx. This is another very important formula. Because you know well here, if you take a spring like this here, then if you compress this one, then what will happen here? Some restoring force will be developed in that, and that restoring force is directly proportional to the extension or the compression. So if proportionality symbol, if you take out, we have to write a constant, and this k is called spring constant. This is called spring constant. Then potential energy here, whatever the energy stored in the spring is equal to, that is work done or energy, both are same. It is half kx square, which is another very important formula in this one. Means in stretching the spring or compressing the spring, in both the cases we will do some work. That work will be stored in the form of energy in the spring. That energy equal to half kx square. You have number of questions on this concept also. That's why I told this one also. Then one more important concept I am going to explain you here is, say for example, here is a pendulum of mass m. Then this pendulum length is L. Let us suppose this is totally not lifted, but it is taken to certain position like that. So this is pendulum, you have lifted like this. Then by making an angle theta. So then in lifting the body from here to here, I have done some work. That work will be stored in the form of potential energy. So how much potential energy? Then how much height you have left? You have lifted it. Let us find out. If it is L, then you know well here, this is L cos theta. This is from up to here, it is L cos theta, here to here, because this is a right angle triangle. Cos theta is equal to adjacent by hypotenuse. If you are not understanding, no worry. You just remember this. Then this height we want. So total here to here is L. Total from here to here is
L.
But here to here is L cos theta. But we need only this height. It is L minus L cos theta. Therefore, work done is equal to force into displacement. Force is mg and displacement is L minus L cos theta. Then mgl into 1 minus cos theta. So directly you can use this formula to find out the potential energy or work done lifting. This work done will be the potential energy in this. This is another very important question which you will be asked. Say for example, if this totally lifted to the horizontal like this. So originally it was like this. Now it is lifted like this here. So angle is equal to how much? 90 degrees. In that case, potential energy is equal to how much? mgl into 1 minus 0 cos 90 0. Therefore, PE is equal to mgl. I hope you understood. These are very important concepts here. You just remember this and you can easily solve mgl into 1 minus cos theta. Then perfectly horizontal if you make cos 90 becomes 0. So this. Instead of this pendulum, say this is pendulum means this is a string of negligible mass. Mass is not there. Instead of this one, for example, if you take a scale, like this is another very important concept whose mass is m, length is l, and if this scale is lifting like this with angle theta, then in this case PE is equal to mg L by 2 into 1 minus cos theta. The reason of L by 2 is when mass is spreaded right from the bottom to top uniformly. Earlier, mass was concentrated only at the bottom. The whole is string. String has no mass. So total mass of the bob is concentrated here. So that's why total length you took. But when rod or a scale is taken, the total mass you are not supposed to consider because the whole mass will be concentrated at its center of mass. You know well. When the mass is spreaded like this, the whole mass will be concentrated at the center of mass, which is at a distance of L by 2 only. So that's why we have to take L by 2. So this concept you remember. If the whole mass is located at the bottom, total length you take. If the mass is located at the center of mass, you can take L by 2. Like example, you will be getting like this only. Like this also. If you take a tank and the tank is full of water, earlier it was empty. Now it is full of water. Now what is the potential energy? Here also you have to take only half of the height. Total height is h only, but its mass is concentrated high here. So it is h by 2, then mg h by 2. So now you got a very clear concept. If the total mass is located at the bottom, whole length you have to take. But if the mass is spreaded right from the bottom to top, only you have to take up to center of mass. I hope you got it, and like some more examples also you can do that. And this is very, very useful lesson today what I explained about the potential energy. And tomorrow we are going to discuss about kinetic energy and law of conservation of energy and work energy theorem in detail. And after that, power. So all these we have to discuss in the next sessions. Now today this is enough. I hope you understood very neatly, very cleanly, and 100% this concept will help you a lot. You practice repeatedly and you invite your friends, suggest your friends this much of important information I am delivering. So let them use that one. I hope your friends will use this information and you will 100% crack the NEET examination with successful physics attempt. All the best. Good luck. See you in the next session.